Hey everyone, welcome to another edition of e-learning with yours truly. What we're going to talk about today is writing sequences, actually more so just interpreting a sequence and finding the nth term or a general term, whatever the heck that means. So before we do that, I kind of want to show you guys a meme. Not gonna lie, I made this on my own, but I'm basing it off um, a meme theme that already exists. So, if you remember when you took Algebra 1, you were introduced to equations. And then later on in the year, and even when early in our year, we talked about these written as functions, which more or less are pretty much almost the same thing. It's just functions have a fancier notation. Um, They also have to pass the vertical line test, and every input has to have its own output, yada, yada, yada. But really, essentially, they're almost the same. I mean, if we were to make a table for our equations and say we have x is 1, we plug the x in, we plug the 1 in for x over here, and we get 3 as our y. And if x is 2, we get 5. If x is 3, we get 7. If x is 4, we get 9, and so on, so on, so on. And if you notice, each of these is going up. Each of the y values go up by 2, hence why our slope is 2, right? So as functions, we would have the exact same table, except for y, we would have f of x. And I'm just going to use the same numbers here. And if x is 1, f of 1 would be 3. If x is 2, f of 2 would be 5. If x is 3, f of 3 would be 7. F of 4 is 9, and so on, so on, so on. So, again, more or less the same. So, in this chapter, we're going to learn about a new way of writing these. So, just in case you're getting kind of bored with the two that already existed, and we're going to be calling this the general term, general formula or sequence formula. So you can call it the right up. These are just patterns for the nth term. And what do I mean by nth term? So if you notice, the variable they're using in this form is an n. That's because whenever we write patterns or sequences, we use n as our variable because they're just numbers in the pattern. So if you remember I'm just going to write these over here. F of 1 was 3, f of 2 was 5, f of 3 was 7, and f of 4 was 9. So if I were to list these numbers out, and these are my n numbers, so I'm going to make a sideways table. Not that you have to, but just it'll be easier to compare. So we have 1, we have 2, we have 3, we have 4, and so on, so on, so on, until we get to whatever number, however many n terms there are. So that's my fancy n. And this would be a sub n. Okay, so when n was 1, just like in the previous two, in the previous function and the equation before that, we would have 3. Okay, and if n was 2, we would have 5 and 7 and 9 and so on, so on, so on. So the reason they use n is because all these numbers all these numbers up here are numbers that are in a pattern. So if I were to say, what's the first number in this pattern? Okay, so if I list the numbers out, I'm only going to list whatever the y values were, 3, 5. So this is our sequence or pattern, okay? So if I'm asking what's the first number in this pattern, the first number is 3. What's the third number in this pattern? The third number is 7. So now watch how I'm going to write this. I'm going to call this 3 a sub 1. The 7 was our a sub 3. Kind of like how our f of 1 in a function notation, whoops, that is not a highlighter. Oops. That's also not a highlighter. Okay, so, whatever, you get the idea. Okay, that thing. If I'm asking what is f of 1, I'm asking for when x is equal to 1, what was the y value? And the y value was 3, so f of 1 is 3. This is kind of the same concept. If I'm asking you what is, in this pattern, what's a sub 1? You see how I'm replacing the n with a 1? Kind of how, like, we're in our function notation, we replace the x with the number in the parentheses. It doesn't mean y equals 1. It just means when you have 1 in for your x, what is the end result? So what this is saying is when I plug in 1 for n, I'm really asking what's the first number of the pattern. So the first number of the pattern is 3. What was the third number of the pattern? The third number was 7. The fourth number is 9. And in the book and in the math world, we ask for any nth term, meaning for any nth number, what do we get? So that's where you would just plug in the formula, which is 2n plus 1. This is basically telling people that, hey, if you want to know what any number in the pattern is, all you got to do is plug in the number that you're trying to find in that pattern, and that'll tell you what number is in that, what term is in that particular part of the pattern that you're looking for. So, okay. Sorry if that's confused, if that wording was confusing, but hopefully, with about 15 minutes, what feels like into this video, you get what I'm trying to say. So that's what that is. And the reason they use n instead of x is because, well, when we're talking about patterns, I'm only going to have whole numbers, or usually they just use counting numbers or natural numbers. You're only going to have 1 or 2 or the third number in the pattern. We're not going to really use decimals. I don't like. It's kind of weird if somebody says, "Hey, what's the second and a half number in this pattern?" I wouldn't be friends with that person. You know what I mean? I wouldn't trust that person. So we use n's to represent. These are like natural numbers. These are just regular numbers, as opposed to x, where it can be any real number. So we're going to do a couple examples, but I kind of feel like changing things up a bit. Oh yeah, this is happening right now. I'm standing right here in the flesh. Well, more like a virtual flesh, if you will. And we're going to do some homework-ish problems together. But first, why don't you just check out this awesome magnet. Thanks to the Staff Appreciation Week Planning Committee for giving this. I think this is so cool. I'm going to display it right here and keep it here. They also get this awesome face mask, which I don't really need to wear right now because I am alone and maintaining extreme social distancing. So thank you for that, and this is a great way to remind us all that we're Evan Strong and we're in this together, and there's a lot that we're doing. There's a lot on your plates, on all your other teachers' plates, on everyone in the ETHS community. So I think this is an awesome way to show and motivate how strong we all are together. And as students, I want you guys to show how much we appreciate you as well for going above and beyond for what you're doing and how you're handling the situation. So, what better way to celebrate with some math, huh? Okay. First of all, yeah, I have a dry erase board in my place, in the kitchen actually, because why not? So, here's an example of a homework time problem. It's asking, it's saying given the nth term of a sequence, so a sub n is equal to n minus 4 times n minus 2, quantity of n minus 4 times the quantity of n minus 2, I should say. So notice how this is the formula. It's not written as a function. It's not written as an equation. So like I was saying earlier, this is written as a sequence. So you have the nth term of a sequence, and for part A, we're going to find the first two terms. So if you're finding the first two terms, well, where are you starting from? So, well, if you're starting from a pattern, or if you start counting, where would you start from? I'll give you a minute. I mean, it shouldn't take a minute, but there you got it. It's exactly one. So, if you're wondering how the quarantine has been for me, hopefully this answers your question. So, we're going to find a sub 1 first, and we're going to do that by plugging in 1 for this n and for that n. Okay? So this gives us -3 times -1, which is a +3. So that's the first term. The second term, and I will move these over to the side in a bit, we'll have 2 minus 4 times 2 minus 2. This is going to be 0, and -2 times 0 is just going to be 0. Okay? So those are our first attempts. We're done. Part B is asking to find a sub 10. C is asking to find a sub 15, which is, let me move this over. Okay, so a sub 10, which really just means replace your n with 10. And no, I did not pick that number to sound like a poet who didn't even know it. It's just, it's just how I roll naturally. All right. I'm also using my headset, so if I'm like all up in your face yelling, my bad. Okay, so we got 6 and 8. That's 48. And we got 15. For a sub 15, you're going to plug in 15 for that. Oops, my bad. And 15 for that. Okay, I'm really nervous. My bad. Giving us 11 times 13, which is going to be 143. You can check the math. I did not do that with a calculator. All apart. Okay, so, and the last problem says find the indicated term of the sequence a sub n is equal to 2n plus 3 quantity squared, and there's a semicolon, so and with an a sub 6, so this is the indicated term. Find the sixth number of the pattern. It's not 6. I mean, it could be 6, but it's really saying what is the sixth number in this sequence. Okay, this would be 12 plus 3, giving us 15 squared. 15 squared is going to be 225. So a sub 6 is 225. So the sixth number of this pattern, if we were to list out all the numbers of this pattern, one by one, we would get 225 as the sixth number of that pattern. Okay, there's one more homework example I want to show you where you're actually generating a formula to find the nth term of a random pattern, which is kind of what yesterday's e-learning I don't know why I'm saying kind of. It's actually literally what yesterday's e-learning was about, and it was just kind of like just to see how many patterns that you can find on your own. So I'm going to show you a one very cool way of doing it using technology that a couple of you actually did, and I was really impressed with you doing that. That was awesome. And if you didn't, hey, get your TI-84s out, the ones that hopefully all of you have downloaded in your Chromebooks, and let's get back to, let's change the scene up a little bit, if you will.